I'm going to explain how to do number 85 from the homework. What I've done is I created two rectangles here that are exactly the same. The only difference is if I show you, if I were to slide, if I were to use the scissors and slide this over here, notice that when I created this one, I put like a little plus sign where the origin is so that when I shift or rotate this, you can see how I'm rotating it. So I made two triangles so that you could see the rotation that's happening between these 2 points. I know that they don't line up exactly. It should be like about there. So what I want to do first is talk to you about the first question here. Does the shape you graphed appear to be a rectangle? So it does look like it's a rectangle, but we can't say it for sure until we find out if those angles are perpendicular or if those angles are right angles. So what we can do is we can find the slope of each one of these lines here. And if the slopes are opposite reciprocals next to each other, then that means that they're perpendicular. So if I try to find the slope of AB, I'm going to use that slope triangle, which means I have to rise 2 and I have to run 1, 2, 3, 4. So this slope would be 2 over 4, which reduces to a half. So that would be my slope for that first line. Now my slope for line BC is going to be to go down and to the right. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go to the right 1, 2, 3, 4. So then since I'm going down 8, that would be a negative 8 over 4, which also reduces to a negative 2. So the slope of BC is a negative 2. Let's go ahead and find the slope of DC. So I would have to go down 2 and to the right, to the left 4. So down and to the left 1, 2, 3, 4. So then the slope of DC would be negative 2 because I'm going down, but then I'm going to the left 4. So two negatives make a positive 1/2. And then we've got one more side that we've got to find the slope for. We're going to go down and to the right. That's down 1, 2, 3, 4, 5, 6, 7, 8. And then to the right 1, 2, 3, 4. So this slope would be a negative 8 over 4, which would then reduce to a negative 2. Okay. And so now what we want to do is we want to compare our slopes. So if you look at the slope of AB, which is a half, and then you look at the slope of BC, which is at a negative 2, or you want to ask yourself, so are these opposite reciprocals? Yes, they are opposite reciprocals, so that means we've just proven that these two lines are perpendicular to each other, therefore that angle has to be a right angle. And then you would go around to do that for the rest of these slides. So now we're looking at BC and DC. Are those opposite reciprocals to each other? They have the different sign, and then they flip the fraction. So then once again, yes, we've proven that these two lines must be perpendicular to each other, therefore creating a right angle. And then if you continue to go around the circle, we have 1/2, and then a negative 2. Those are opposite reciprocals, so they must be perpendicular as well. And then you will compare the last set we have here, which is your negative 2 and your positive 1/2. And then yes, those are opposite reciprocals, so then these two lines must be perpendicular to each other, so then they must be right angles. So use slope to justify your answers. So I've done that. So I could say consecutive sides have opposite reciprocal slopes. And then I showed you what those slopes were to prove, yes, they are opposite reciprocals. For part B is the clockwise rotation about the origin from A prime, B prime, C prime, D prime. What are the coordinates of the vertices? So I created this other triangle over here in the beginning so that we can kind of move it and rotate it. So if I set it here and then I want to rotate it 90 degrees, you're going to see that if I kind of turn it this way and I keep that point on my origin, then the 90-degree rotation would be this way. And you know what? Maybe it would even help if I put an arrow on that original. So like I'm facing, oh, no, I don't. Do I want to cut that? Yes. So hold on, let me make that. Okay, so I'm going to put an arrow on that north so that we know that that was facing north. And so now when I go back and cut this and put it here on top of the green one, and then I rotate it, then my new 90-degree rotation should be sitting here. And so now the arrow's pointing to the right instead of up. So that tells me that I've done that 90-degree rotation. And so now what I can do is I can look at the new red points for where those are. You have to remember that when I rotated it, my points were off a little bit. So I hope that helped you. What are the coordinates of the vertices? So now you can just go back and you can write in what these coordinates are. All right, I gotta go start my class. So I'll deliver this in a little bit.